going to work 2, 4, and 8 on your homework. Okay, number 2, copper 2 nitrate. You need 2 nitrates because of the -1 charge. Plus iron. Iron is a metal and can be by itself. It reacts with the copper nitrate to produce iron 2 nitrate. And copper. I need to balance the equations next. After I write the correct formulas, I'll start with the polyatomics first. I have a nitrate on the reactant side, and I have a nitrate on the product side. I have 2 of them, so I don't need to do anything to that. I have one copper on the reactant. I also have 1 copper on the product. I don't need to do anything to that. I have 1 iron on the reactant and 1 iron on the product. So they are all the same. So I do not need to add any moles to balance it, but I would have this on it as far as 1's in front of it. So that's the correct equation for number 2. Number 4, let me go back. Number 2 is a single replacement. This is the one where we put the nail in the blue solution. What happens is the blue solution contains copper, and that copper is going to react with the iron in the nail, and the copper from the solution will be deposited on the nail, okay? And it produced quite a bit, and actually produced a whole bunch that it fell off. And the iron from the nail will go into solution, so we're going to replace the positive ions. The copper will replace the iron in the nail, and the copper will precipitate out. So it's a switch between the positive ions in this case. Excuse me. Number 4. Station number 4 was where we had the yellow solution and the clear solution. Potassium chromate. Potassium is plus. Chromate is CrO4, and it's a -2, so I need 2 potassiums. It reacts with silver nitrate, silver plus 1, nitrate -1, so 1 of each. It will produce silver chromate. Silver is a plus, chromate is still a -2. And it produces potassium nitrate. The balanced chemical equation. I have polyatomics. I have chromate CrO4, and I have polyatomics NO3. I would start there, but there's 1 on both sides, so I'm not going to start there. But silver has 2 on the product side and only 1 on the reactant side, so I'm going to put a 2 in front of AgNO3. That will give me 2 silvers and 2 nitrates. I only have 1 nitrate on the product side, so I need 2, so I will put a 2 there. That changes my potassiums to 2 also. I have 2 on the product, So this is the balanced equation, correct balanced equation. This is a double replacement reaction. When two aqueous solutions react together and we produce and form a precipitate, the silver chromate is the precipitate. It is the brown, reddish brown substance that fell to the bottom, but it only happens in a double replacement. The last one, this is where we had the watch glass and the flammable solution. The solution was isopropyl alcohol, so it has that chemical formula C3H8O. In order for isopropyl alcohol to burn, we need oxygen. Remember, oxygen is diatomic, so you have to have two oxygens. This is a combustion equation. A combustion equation has oxygen excuse me, as a reactant, and I usually have a whole bunch of C's and H's over here as a clue that I have combustion. But since I have the products here, a combustion equation always will produce water and CO2. Since this is a combustion equation, I need to start with the C's first, and then I'm going to balance the H second, and lastly the O. I have 3 C's on the reactant side, but only 1 on the product side. So the only way to get that to become 3 is put 3 moles in front of CO2. Since I'm not balancing O yet, I'm going to go straight to the H, so I'm not going to count up my O's. I have 8 H's on the reactant side, but I only have 2 on the product side, so the only way to fix that is with 4 moles. Okay. Once I fix C first and then H second, I'm going to count up how many O's I have. On the product side, I have 1 O here and 2 O's there, so I have a total of 3. On the reactant side, I have I got 4 O's, because 4 times 1 is 4, and plus 3 times 2 is 6. I have 10. Okay, I have an issue. So I've got to figure out how do I get the oxygen to be equal. And so it becomes a little tricky, and so with the alcohols, I'm going to So they get a little tricky, and so I have 10 O's on the product and 3 O's on the reactant. So one way to do this is I got to think, what times 2? So I'm looking at this one right here. What times 2 plus this one right here will equal 10. All right. So what times 2 will give me 9. So I'm trying to find out what times 2 will give me 9, and what times 2 times to give me 9 is 4.5, and it is okay to have a half, okay, because 4.5 times 2 is 9, and 9 plus 1 is 10, so it is balanced there. If I don't like the half I have the fraction here, the 4.5. What I can do is whenever I do that, I can double everything. By doubling everything, it puts 2 moles of isopropyl alcohol. 4.5 times 2 is 9. But if I double everything to balance it, I have to also double the product side. So that becomes 8, and this becomes